With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students. The question is, which among the following statements is correct with respect to the optical isomers? Okay, so here 4 options are given to us and we need to tell out of all these 4 options which one is the correct for the optical isomers. Alright, so if you see here, first of all we should know what is optical isomers. Optical isomers are those isomers which are mirror images of each other and they are non-superimposable. They are what? They are mirror images of each other and non-superimposable. Mirror images of each other and non-superimposable. Okay, that means they will not impose on each other. They will not superimpose on each other. Alright, non-superimposable. Now, they also have a property that they can rotate plane polarized light. Okay, so first of all we should know what is optically active and chiral center. See, chiral center is a center which has all 4 different substituents attached to it. Okay, see, this is a carbon. Here let's say A, B, D are the substituents which are attached to one carbon, and since all the 4 substituents are different, this carbon will be our chiral center. Okay, chiral center, if this is a chiral center, this will be a chiral center, right? Then this will possess optical activity. Optical activity, and this compound will be optically active. Okay, so this will possess optically. This will be optically active, okay, and this will possess what? This will be an optically active compound and this will possess optical activity. Now, what do we mean by optical activity? It means that a compound having a chiral center will be able to rotate plane polarized light either to the right or to the left direction. That is our optical activity. Okay, so thus in meso compounds, if you see in meso compounds, we should have minimum 2 chiral centers must be there. Okay, then a compound can be a meso compound. Alright, then only a compound can be a meso compound. Okay, so now, and these are optically inactive compounds. These are optically inactive compounds. Okay, A is enantiomers are non-superimposable mirror images, which is correct because we know that enantiomers are what? They are non-superimposable mirror images. So this is a correct statement. If I give you an example, so let's say this, we have an example. Let's say we have here CH2OH and here we have a CHO here, CH2OH here, OH here, OH, H and OH, hydrogen. Okay, so this is hydrogen. Let me draw this again. So it is like this. CHO is here, alright, and we have a CH2OH here. Okay, so if you draw here OH and OH, H and H. Okay, so if you draw its mirror image, what you will get? On drawing the mirror image will be what? It will, OH will come here, its OH will come here, H here, CHO and CH2OH. So this is a chiral center, this is also a chiral center, right? So same here, this is also a chiral center and this is also a chiral center. So if you see, these 2 are mirror images of each other, right? But if you pick this one up and put it on this, will this OH will come on this H and this high H will come on OH, right? So thus they will not superimpose each other. Superimposing means that the same atom should come on the same place. That means let's say if OH was there here only and if you put it up and keep it here, then OH will come above OH. Okay, that means it is getting superimposed. But here as you can see, if you pick this up as it is and then you put it on this, then what you will get from on OH, H will come. Okay, and on H, OH will come. So that means these are mirror images of each other, right? And they are non-superimposable. They are non-superimposable. Okay, so thus what are these? These 2 are enantiomers. So thus this proves us that enantiomers are non-superimposable mirror images. So thus A statement is the correct statement. Alright, now diastereomers are superimposable mirror images. First of all, we know that diastereomers are not mirror images of each other. They are not mirror images of each other. Okay, and why so they are not mirror images of each other? Because they are different from each other. That means if I just give you an example, let's say I'll take this example again. We have a CHO here, we have a CH2OH here, we have a Br group here, H, and OH here, and a H here. Okay, so if so its diastereomer will look like this. Okay, they are not, as I said, they are not mirror images. Its diastereomer will look like this. CHO, Br is still there on its place, but OH, the position of OH has changed. CH2OH. Now, if you see these two are diastereomers of each other. Okay, and as you can see, they are not mirror images. Why? Because Br is still on its place. If you would have drawn the mirror image, then the Br has to come on the left. But it is not. So thus, this is what? These two are diastereomers and they are not mirror images of each other. So thus, if they are not mirror images, they cannot be superimposed on each other. So thus, your B statement is the wrong one. Okay, so your C statement is enantiomers are superimposable mirror images. So I just showed you in this example that no, they are not superimposable, they are non-superimposed. You cannot superimpose its mirror image on the first one. Okay, so thus enantiomers are not superimposable mirror images. So thus this is also an incorrect statement because it is saying that they are superimposable, but in actually they are not. So thus this is the wrong statement. Last is mesoforms have a plane of symmetry. So we know that mesoform, this is the right statement because mesoforms do have a plane of symmetry.
And what are mesoforms? Mesoforms are the compounds which are optically inactive but they have minimum of 2 chiral centers, and in spite of having 2 chiral centers they are still optically inactive because of plane of symmetry.
This, let's say I'll take an example of mesoform here. Let's say this is H, OH and H, this is also OH, and this is H, and this is also H. Okay, so if you see, there is a plane of symmetry in between here, right? If you fold this molecule, your H will come on H, OH will come on OH, and H will come on H, right? If you pass a plane from between, from the line that I've drawn, OH will be on the place of OH, H will be on the place of H, and this H will be on the place of H as well, right? So this is what? This is a meso compound. Or if I show you one more example, like this only, if you put like this, CH to OH here, again OH here, H, and CH to OH. Okay, so if you pass a plane from here in between, then also use a superimposable mirror image will come. So this is a meso compound, this is a superimposable. Okay, although these two were not chiral centers. Okay, this and this is not a chiral center. This I've just taken an example just to tell you what is the plane of symmetry. But if you see this carbon and this carbon, this carbon and this carbon, both of them are what? Optical centers, right? Chiral centers. What are chiral centers? Which have all 4 different substituents attached to it. So here, if you pass the plane from here, then you will get a plane of symmetry will be there because OH will be on the place of OH, H, and CH2OH. CH2OH will come on the same. Alright, they will reflect each other. So thus, this compound has a plane of symmetry, and thus it is a meso compound. So thus mesoforms have a plane of symmetry. So yes, they have a plane of symmetry. Okay, so thus your correct options are 2, A and D are the correct answers. I hope you understood. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.